All right, so yesterday in part 1 we looked at writing an explicit formula. Today we're going to look at writing a recursive formula. So a recursive formula works on certain kinds of sequences. There's a Fibonacci sequence, you may have heard of that, and it can only be used as far as writing a formula using a recursive formula. And so there's two parts to it. There's the rule, which is a sub n equals a sub n minus 1, and then plus whatever the d value is. So the only thing you're putting into the formula is the d value. Everything else stays exactly the same. A sub n equals a sub n minus 1. So the n minus 1 is the subscript. All right, and then plus whatever the d value is. Then the second part is whatever a sub 1 is, whatever the first term of the sequence is, you have to define what the first term is. All right, so it's always two parts for recursive. And so that's why it says you must write both parts. All right, so we're going to find the first 5 terms given this sequence or this formula in recursive form. So it says a sub n equals a sub n minus 1 plus 4, and they give us the first term, a sub 1 equals 5. And we're finding the first 5 terms. So we already know what the first term is. It's 5. We know a1 equals 5. So to find a2, you can plug 2 in for n in all the in the subscript for all the n's. Okay, so here's our rule right there. And so a sub 2 is equal to a sub 2 minus 1 plus 4. Okay, so all I did was take the rule, plug 2 in for all the n's. Now, a sub 2 minus 1 can be simplified to a sub 1. Right, because 2 minus 1 is 1. But I already know what a1 is. A sub 1 is 5. They give it to me. So I can replace a sub 1 with 5 plus 4, which is 9. So a2 is 9. So I have the first term. I have the second term, which is 9. I can find the third term, and the fourth, and the fifth. Well, I can see that the only thing that's happening is I'm adding 4 each time, because that's the d value, the common difference. So I should be able to come up with my sequence. All right, so 5, 9, I'm just going to keep adding 4. 13, 17, 21. All right, now number 2 is given in function notation instead of a sub notation, but it works exactly the same way. All right, so we know that the first term is 19. So to find f of 2, just so you can see it, f of 2 minus 1 minus 6. 2 minus 1 in the parentheses is the same as f of 1 minus 6. F of 1 is 19 minus 6. And 19 minus 6 is 13. So I have the first term 19. The second term is 13. So then I should be able to come up with the rest. The only thing that's happening is we're subtracting 6 each time. Right. So 19, 13, subtract 6 from 13, that should be 7, 1, negative 5. All right, so now we're going to do the opposite. We're going to write the recursive formula given the sequence. So we have to find the common difference, the d value. All right, so on number 3, how are we getting from 7 to 2 to negative 3 to negative 8? Yeah, we're subtracting 5. All right, so d is negative 5. So when we write our rule, it's going to be a sub n equals a sub n minus 1. That's a subscript. And then the d value, which is minus 5. So that's big. The -5 is a big number. Same font size as your A, where the subscript, those are small, the n and the n minus 1. All right, and then we have to also define what the first term is. So a sub 1 equals 7. So that's how you write this recursive rule. It's always two parts. All right, and then number 4, same thing. We have to find the d value. So what's the d value on number 4? The common difference? Yeah, we're adding 12. Good. Okay, so positive 12. All right, so then our rule, a sub n equals a sub n minus 1, and then plus 12. And then define the first term, so a1 equals 5. All right, so now what we're going to do is look for the sum of a sequence or series. A series is when we take a sequence and put addition signs in between all the numbers. It just means that we're adding all the numbers together. All right, so what I want you to do is take your calculator, and let's do number 5. We're going to add all those numbers up. 2 plus 4 plus 6 plus 8 plus 10 plus 12. Figure out what this sum is. Anybody get 42? Okay. I'll make sure I put it in right. All right, so if everybody gets 42, we're good. All right, so when we have a huge series of numbers and we want to add them together, the last thing we want to do is plug them into the calculator. It could take a long time. You could mess up somewhere by plugging it into the calculator. And so if it's a certain kind of sequence, we have a formula that we can use instead. All right, and so if it's arithmetic and we can see it's arithmetic, then we can use this formula that's off to the side. So this is S sub n. So n, or S stands for like the sum. Okay, sum means you're adding up all the numbers. Okay, and n is the number of terms. Okay, so this is the number of terms you're adding together, or the number of terms that are in your series that you're adding together. A1 is the first term. So you need that first term. And then the a sub n is going to be your last term that you're adding. So the last term of your sequence. So we need the first term, the last term, and the total number of terms. And so what I want to do is let's practice using this formula on number 5. We already know what the answer is. We know it's 42, but we want to be able to plug the numbers into the right place. So then when we use the calculator to actually do the calculation for us, we know that we did it right, okay, for the setup. All right, so the first thing we're going to do on number 5 is we have to find out how many terms we have. All right, so we just count up the number of terms. So there's 1, 2, 3, 4, 5, 6 terms, 6 numbers. So we're finding S sub 6. All right, so 6 is our n value. That's the number of terms. So it's going to be 6 over 2 times. Now the A1 term, that's the first term. That's going to be 2 in this case, plus the last term, which is 12. All right, and now let's just simplify this down. 6 over 2, that's 3. 2 plus 12 is 14. And if you do 3 times 14 in the calculator, it is 42, which is exactly what we got when we just added them up. All right, so now let's see how we can use this formula, because the last thing we want to do is list out every single number and try to add them up. So on number 6, it says, given this, this series, 1 plus 2 plus 3 plus 4 plus 5, and so on, add up all the numbers of the first 50 numbers of this series. Okay, so we don't want to list all 50 numbers out and then try to add them up. All right, so we know there's 50 numbers, and we know that this is arithmetic because what's the common difference? It's 1, right? They're just going up by 1. Okay. All right, so let's go ahead and find S sub 50. All right, so we know that there's 50 numbers, so it's 50 over 2 times. The first term in this series is 1, plus, now we need to know what the 50th term is. Now, we should be able to see what it is. What do you think it is? It's 50, right? Because just because they're going up by 1, we can see that this is the first term, which is 1. The second term is 2. The third term is 3. The fourth term is 4, and so on. And so we should be able to see that the 50th term is 50. All right, so now we just simplify this down. That's 25 times 51. And that's 1275. All right, so now we're going to find the partial sum of an arithmetic sequence. You need, you're going to have to find the explicit formula so you can find the last term. Okay, so let's see how this one works. We know that in number 7, there's 20 numbers we want to add up. All right, so we're finding S sub 20. So it's going to be 20 over 2 times the first term, which is 7, plus the last term, or the 20th term. Well, we don't know what the 20th term is. And the last thing I want to do is list out all 20 numbers, okay, because I could mess up somewhere by extending it out. So what I'm going to do then is I'm going to find A sub 20 instead. Okay, instead of listing them all out to find the last term, I'm going to find A sub 20. So this will give me this number right here. So we have to use the formula from yesterday, our explicit formula rule. That's the AN equals A1 plus parentheses N minus 1 times D formula. So you have it on your notes. Okay, again, that formula will be given to you. This sum formula will be given to you. Okay, you just got to know how to use it. All right, so our A1 term is 7 plus N is 20 minus 1. And then the D value, we can see it's going up by 3. D is 3. All right, so again, I'm just using this formula that's on your notes. Okay, so I plug 20 in right here because I want to find the 20th term. Okay, that's the first term, 7, plus N is 20 also because it says 20's here, and 20's here, minus 1, the common difference. We're adding 3 each time. All right, so we want to calculate this out. 7 plus 19 times 3. So you got to do 19 times 3 first, as order of operations, plus 7. So that's 64. So that means the 20th term in the sequence is 64. Okay. So now I can go ahead and finish calculating this out. So 20 over 2 is 10. 7 plus 64, 71. And then 10 times 71 is 710. So that would be the sum of the first 20 numbers of this series. All right, number 8. Find the sum of the first 100 terms of this sequence. All right, so we're going to do exactly the same thing, just different numbers. All right, so S sub 100 equals 100 over 2 times, the first term is 3 plus, so now we have to go off to the side and find the 100th term, a sub 100. All right, so the first term is 3 plus 100 minus 1 times the common difference, which is 4. Three plus 99 times 4. So that's 399. All right, and we just finished calculating this out. 100 over 2 is 50. 3 plus 399 is 402. 50 times 402, 20,100. All right, and then the last kind of problem is a word problem. And so you're going to have to set up the sequence. All right, in a theater, there's 40 rows of seating. Each consecutive row, so that means each row next to each other, increases by 3 seats. The first row has 15. How many seats are there in the theater? All right. So the first row has 15. So we're going to start with 15. It increases by 3 seats each row. So we add 3, that would be 18 for the next one, and 21 for the next one, and so on. And there's a total of 40 rows. So we want to add up all the seats in this theater. How many seats are there? So we're looking for S sub 40. All right, so it's 40 over 2 times. The first term is 15 plus. Now we have to find out how many seats are in the 40th row. We know how many are in the first row and the second and the third, but we've got to go all the way to the 40th. So we go off to the side and find a sub 40. And we use that AN rule. All right, so A1, the first term is 15 plus 40 minus 1 times the common difference, which is 3. So 15 plus 39 times 3. So 132. So there's 132 seats in the 40th row. All right, so now we just finished calculating this. It's at 147. 2940.